In section 12.4, I'm going to show you a different way to solve a system of equations. It's kind of nice because it's a mechanical approach, and you can use it to solve, all kinds of system equations. In fact, you're not limited to 3x3s. You can do 2x2s, 4x4s, 10x10s, lots of different stuff. So let's start by looking at this problem here, problem number 48. And the idea is that we're not going to actually try and solve this by hand. We have to understand a little bit about computers, graphing calculators, and how they work. And what they work with primarily is numbers. So on the left-hand side of this, let's look at just the number part. And the number part of this is the coefficients. So on the left-hand side, the coefficients are 2, -3, and 3, 3, 3, and -1 for the z, and -2, 6, and 5. So those are the coefficients on the left-hand side. Now leave about a finger's worth of space here before you write the equal sign. And we're also going to do the right-hand side. So 14, 2, and 9. That's our right-hand side. Now these things are called matrices. And because we're kind of getting rid of the variables in this case are kind of understood by their position, that's closer to what calculators work with. So a matrix is discussed by its dimensions. So matrix. When you talk about matrices, you talk about their dimensions. And their dimensions are always given in the order of row and then column. It's important to keep that in mind so that when you enter these things into your calculator, you get what you expect. Now, what a lot of times I'll joke with is that I have a corporate sponsor for this class. And this class is sponsored by RC Cola. You don't see RC Cola around anymore, but I used to find it around here and there. The last time I had somebody find it was at a vending machine at Michigan State. So go figure. All right, but that RC is important so that you remember the dimensions are in the order of row and then column. So it's always in that order. So with that said, this is what's called a 3x3 matrix. 3 rows and 3 columns. Now here it doesn't matter if you mix up row and column because they're the same. But here it does. If I'm talking about number of rows and then columns, what's the dimensions of this one? This one over here. It's a 3x1 matrix. So there it does make a difference because a 1x3 matrix would look a lot different. Now, how is this going to work? Well, it's not really, on one level, it's not much different than what you've done with other things. For instance, if we have 5x equals 45, most people just solve it right away by dividing by 5. But let me ask you to think of it a different way. Instead of multiplying, or instead of dividing by 5, I can multiply by the inverse or the reciprocal of 5. The reciprocal of 5 is 1/5. So 1/5 times 5, all right, they cancel, and I get my solution, right? It's just the inverse times the right-hand side. We're going to do that, except on a bigger level, with matrices. So what's that look like? Well, I need to add in a little something here to make this a complete matrix equation. And that would be an x and a y and a z. And now I'm going to give these kind of matrix names. And hopefully it won't be confusing. I'll call that matrix A. This is matrix B. And even though I've used x up here, I mean kind of a different x, I'll use kind of a capital X there. Matrix X, which is just really this column right there. AX equals B. Now, it's not something that you really need to know or be aware of, but essentially, in a matrix way, we're going to do the same thing here that we did over here. We're going to multiply both sides by the inverse. Now the inverse is something I'm going to hide from you. It's not a calculation you're going to do or even understand until you get to college algebra. But it's pretty involved. The good thing is that our calculator is going to do it for us. So here's what's going to happen. I'm going to multiply both sides by the inverse of A. And these are going to cancel each other out. And what I'm going to get is my solution. X equals A inverse times B. What that means is that if I could get my matrix into my calculator somehow, that all I have to calculate is A inverse times B. And I'm let my calculator do the rest of the work here. So let's practice that. This is going to be our matrix A right here, and this is our matrix B. So take out your calculators. Now if you look right above the X inverse key, what do you see? Yeah, you see matrix in blue. So what do you have to do to get to that blue key? Second. So second in the matrix. Now, because a lot of you are using borrowed calculators, you might have some stuff in there already, and that's okay. What you want to do here is cursor over to edit, and then select, either by cursoring down or just typing the number, what matrix you want to enter or edit. So I'm going to type a 1. Now if you don't have anything there with your matrix, or there wasn't there something there to begin with, that's fine. You need to type in the dimensions. Ours is a 3 by 3 matrix. Okay. Then it's going to ask you for the coefficients. So let's type in the coefficients that are part of our matrix. So that's these numbers. So just type in the number, press enter, and it should cursor you all the way through the matrix. So it'll look like this: 2, -3, 3. I ended up with a negative 33. All right, so let me go back there. -3. There we go. 3, 3, 3, -1, -2, 6, and 5. So you should end up with matrix A all nice and neatly entered like that. Are we good there? I don't want anyone falling behind because you'll miss out. Nick? All right. All right. Let me teach you an Arabic word. You probably already know. Yalla. Yeah. All right. You know, in meeting students from all over the world teaching here, I get to learn little bits of different languages. You know, in Russian, hurry up is bistreya. In Albanian, it's spät. But my favorite is Hawaiian, because hurry up in Hawaiian is wiki, which just sounds really polite, you know. All right. So once you enter this, let's quit. We got to get out of here. So press the second button, then the mode key, which quits you out of there. And then as fast as we get out, we got to go back in, because we got to enter matrix B. So we got to do this again. So hit the second key, then the X inverse key. This time, go over to edit and select the second matrix. And here's where it's important to know the dimensions in the right way. What comes first, rows or columns? Rows. RC cola. Good. So rows come first. So a 3 by 1 matrix, and then type in matrix B, 14, 2, and 9. So that's matrix B. Let's quit. So second, and then the mode key, and exit out of there. Now, if you want to just make sure that, gee, I typed these things in right, and it's not a bad idea, you can make your calculator type out those matrices, hit the second key, then the matrix key, type the number 1, and then press enter. And it'll show you what you have for matrix A. Make sure that that's what you're supposed to have. You can repeat that process for matrix B. Again, make sure you've got what you're supposed to, etc. All right. I've done a lot of setup, an awful lot of setup. But really, your part in this, your calculation for finding the inverse is pretty simple. We need to type in this little piece right down here, A inverse times B. So here it goes. Hit the second key, then go back to the matrix menu. We want matrix A, so type the number 1 or press enter. But I don't want just the matrix A, I want its inverse. So type the inverse key. That's the x to the negative 1 power. Times matrix B. Well, I need matrix B now. Where do you think I'm going to go to find matrix B? Second, and back to the matrix menu. This time, press the number 2. So you should have A inverse times B, and then press enter. And that's your solution. Ooh. Now, if you don't recognize the decimal negative 0.33333, you can hit the math key right here. So let's press that. To convert your answers to fractions, press enter twice. Essentially, once you've hit the math key, and there it is. That's x, y, and z. All done. Pretty cool. Way cool. Come on, give me some love on that one. All right, yay. All right, that's good. Thank you. But that's it. There's your solution. Wow. So overall, 2, negative 1/3, and 3. You're not just limited to doing this for 2x2 equations or 3x3 equations. You can do it for 2x2. You can do it for 10x10, whatever. So, no, I'm not going to ask you to do anything. I couldn't even conceive of doing anything above 5x5 in this class. Even then, 5x5 I'd have you doing it on a calculator. The only thing you're going to have to do by hand will be one of these 3x3s. I'll ask you to do one by hand. But let's go back to problem number 22 from the previous section. Let's practice setting these things up again. You might remember in problem number 22, we ran into this little problem. And it was kind of a lot of work to solve that by hand. Remember, we had to divide by 3, and it was a pain. So let's see how that would look solving this as a system of equations. I'd first start out by figuring out what matrix A is going to be. What's matrix A going to be in this case? 12, negative 7, 9, negative 3. And matrix B, 74 and 51. So let's enter both of those into our calculator and then repeat this calculation of A inverse times B. So go back to matrix. Now it's important that when you go back here, you go to edit and then select the first one. What's the dimensions of this matrix? 2 by 2. So 12, negative 7, 9, and negative 3. Once you get that entered, quit. So hit the second key, then the mode key. Then go back in, and I know it's kind of a pain. Go over to edit first, and then select matrix 2, or matrix B. This time a 2 by 1. And I want 74 and 51. It's too much work? Maybe for a 2 by 2, but what about for a 3 by 3 or a 4 by 4? I mean, really, these systems of equations get absolutely huge. What do you think a big system of equations would be? 100 by 100 is extremely small. They solve these on the order of millions by millions. Millions. Like a friend of mine was telling me about some work he was doing. They were solving a system of equations that was like is it 2 million by 30 million or something like that. So, which is even more of a pain because it's nice if the number of equations match the number of unknowns. His didn't, but it was huge. Yeah, computers, absolutely. All right, so let's go back. Now, you should practice typing in A inverse times B. Make sure that you can still do that you know those commands. All right, so to get A inverse, you need to type matrix A. So second and then matrix. That gives you this. Then either press enter or type the number 1. That'll give you A. The inverse part is right here. So you press that. A inverse. And then we got to repeat this for matrix B, second, and then the matrix NU. Select B, and there you go. So you get 5 for X, -2 for Z, like we got earlier. Okay. How are we looking on that one? All right. Let's go back to section 12.2 for a second. Remember at the end, we solved this one, or at least we tried to solve it, and it came up with the fact that this was an inconsistent system. What's going to happen if you try and solve an inconsistent system on your calculator? Well, let me show you. And maybe just sit back and relax while I do this one. I need to type in matrix A. Maybe you can help me with matrix A. So matrix A, first of all, it's going to be a 3 by 3. Can anyone tell me the coefficients there? 3, 4, 1. Good. 1, -2, 1, 2, 1, and 1. Thank you, ladies. So I'll quit out of there. And then I need to enter matrix B, which is going to be a 3 by 1, which is going to be 10, -3, and 5. And for those of you who are pretty comfortable with your calculator already at this point, don't need to practice it, let me show you another trick. I've already entered in A inverse times B several times. It's in the history of my keystrokes. If I want to go backwards, I'll hit the second key, and then the enter key, and it brings up my most recent calculation. So good. I don't have to type in all those commands again. I've already done that. And just press enter, and uh-oh, I get this error message. No inverse matrix exists. And basically what that's telling you is, okay, it's an inconsistent system. There's really one of two possibilities. It's either dependent, meaning you have lines that meet along, or planes that meet along a line, infinite number of solutions. Or what else could be happening? Or you could have things that are parallel so that there's no solution. Either way, there's no solution. And that's what we really got to worry about. Okay, are you comfortable with doing these, on a calculator? Can you do those? Here's the benefit. All right, now let me get around to showing you this, and that is, once you can set those up, or once you can solve those quickly on a calculator, then really the question is, can you set up certain problems? So you might have noticed we skipped section 12.3. Yeah. That's the application section. What I'm thinking of is that probably what I'll have you do in this section is set up the problem, but then solve it on a graphing calculator. So you're going to get a 3 by 3 system of equations, but then it'll be pretty easy to solve. You won't have to sweat it. And mostly what I'm testing you on is, can you set this up? And I have to think that in your modern world, where you've got computers and you can Google just about anything, the question is not, can you solve this by hand, but can you set it up correctly? Because if you can't tell the computer what to solve, what good's the computer, right? So let's practice solving or setting up two of these. And the first one is going to be this nutritional planning one here. So let's see what's going to go on with that one. And let's see if the author is a little bit better than our last textbook. The last one, it was funny. They wanted to plan a meal with like 5 grams of protein, 5 grams of carbohydrate, and 10 grams of fat, which just sounded nutritionally, maybe delicious, but nutritionally backwards. All right. My dad teaches nutrition, and if I even dream of eating a Twinkie, I wake up and apologize. I'm really conditioned. Okay. All right. It's not quite that bad, but 1 ounce of 3 foods has the vitamin and mineral content shown. How many ounces of each must be used to provide exactly 22 milligrams of niacin, 12 milligrams of zinc, and 20 milligrams of vitamin C? So here's the chart. Now let's list down below here all the different amounts. We wanted 22 milligrams of niacin. It's one of your B vitamins. Zinc's a good mineral. And we want 12 milligrams of zinc and 20 milligrams of vitamin C. Okay. So that's going to lead us to a system of equations. The question is, how much of food A, how much of food B, and how much of food C? And I've gotten off here. Well, if I want a total of 22 milligrams of niacin, my niacin comes from 1 gram for food A, plus 2 grams for food B, plus 2 grams for food C, and that should equal a total of 22. So do you see how I got that equation by multiplication? 1 times A, 2 times B, 2 times C. Can you set up the next equation? So the next equation would be for zinc. 1A plus 1 times B plus 1 times C equals 12. Now there's a total of 3 unknowns, A, B, and C. If you're going to solve 3 unknowns, you're going to typically need 3 equations. I need a third equation. What's that third equation going to look like? Two times A plus 1 times B plus 2 times C equals 20. So there's your 3 equations and 3 unknowns. And then you can solve that on your graphing calculator. The answer, just in case you're curious or just want to check it at home later, it'd be 2, 4, and 6 for A, B, and C respectively. Are you comfortable with where we got these equations from? All right. Let's try one more here. That'll be the last one. This is a good one. I kind of like this one. And it's going to be a lot easier because we have graphing calculators to finish this up with. Now, you may have heard something along the lines, or certainly you can believe it, that if you have 2 points, 2 points determine a line. So y equals ax plus b. But if you have 3 points, say 1, 2, and 3, 3 points determine a parabola. And the general equation of a parabola is y equals ax squared plus bx plus c. So in this problem, I want to figure out the equation of a parabola that passes through these 3 points. negative 1, 3, excuse me, negative 1, negative 3, 1, negative 1, and 3, negative 7. So let's figure out a system of equations for that. It's going to start by remembering that y equals ax squared plus bx plus c is a very general form of a parabola. And let me write down the three different components, negative 1, negative 3, 1, negative 1, and 3, negative 7. Do you have an ID or keys or something like that? Okay. Let's keep in mind that this is your x and this is your y. If this parabola is going to pass through these points, then these points all fit in this equation. So how does that work? Well, negative 3 should equal a times negative 1 squared plus b times negative 1 plus c. So what did I do? I just put in negative 3 for y and negative 1 for x. And let me zoom out a little bit. Now we'll go back and clean that equation up in a minute. But let's see if we can't do the same thing for the second point. Anyone want to take on the second point? What would that one? Negative 1 equals... All right, thanks, ladies. So again, you're plugging in the x and the y coordinates. The last equation is going to be negative c, or negative 7. Plug in a 3, a times 3 squared plus b times 3 plus c. Now you can and probably should clean those equations up a little bit. It's not too hard to do. So that's going to be negative 3. What happens when I square negative 1? Positive 1. So a minus b plus c. And negative 1 equals, well, a plus b plus c. And last but not least, negative 7. Can anyone tell me what negative 7 would be? 9a plus 3b plus c. What you get when you solve this is a is negative 1, b is 1, and c is negative 1. If you then plug that into your equation, you end up with y equals negative x squared plus x minus 1. Again, that's something you can and should and will solve on a graphing calculator. All right, I'll assign some homework for 12.3 next time. I think you're going to have your hands busy with the other stuff. Good luck. See ya.